Many people are wondering whether 0.9 repeating is equal to 1, but math doesn't leave any room for doubt. It outright proves 0.9 repeating equals 1, because this statement is crucial for the consistency of math itself. Let's explore why 0.9 repeating must equal 1 in mathematics. Mathematics is the art of painting with numbers. Without numbers, mathematics wouldn't exist. That's why math strives to make the number system and their properties as complete as possible. One of the key properties of real numbers is continuity. Just as a number line is unbroken and continuous, numbers must also follow this property. This is why real numbers correspond perfectly to points on a number line. But how are numbers represented? In ancient times, fractions were commonly used. However, after decimals were invented, things changed. Decimals were easier to write and compare, making them the standard way to represent numbers. However, actually decimals had a major problem. In principle, many numbers couldn't be expressed as decimals. 1/2 is 0.5 and 1/5 is 0.2. These are exact, but what about 1/3 or 1/7? If you calculate these with a calculator, you'll see an endless sequence of digits represented as a decimal. Interestingly, this way of representing numbers is directly related to saying 0.9 repeating equals 1. If 1/7 is said to be equal to this value, then 0.9 repeating is equal to 1. Technically, 1/3 or 1/7 cannot become decimals. Decimals were originally just another way of expressing fractions, where the denominator is a power of 10. Only fractions whose denominators are made of 2's and 5's can be converted into exact decimals. Fractions like 1/3 or 1/7 cannot have their denominators turned into powers of 10. In principle, they are not true decimals. This problem led to a need for the solution. It was representing those fractions as infinite decimals, an approach that allows 0.9 repeating equals 1. Let's break it down. 0.9 repeating can be written as an infinite sum. By using limits, this sum converges to 1. While 0.9 repeating and 1 may look different, they represent the same value. 0.9 repeating equals 1. By extending this method, decimals could now represent numbers. Rational numbers like 1/3 or 1/7 became repeating decimals. Irrational numbers like √2 or pi became non-repeating decimals. Ultimately, every real number could now be expressed as a decimal. This ensured the perfect correspondence between numbers and the number line, all thanks to key concepts like 0.9 repeating equals 1. That's why this statement is so essential in mathematics.